All right, but all of that is to serve a purpose because what we did was, well, previously, we discovered that when you had a maximum, relative max, or relative min, we really only focused on the mins. It seemed that the derivative at the minimum point was either 0 or undefined. So it makes sense to find the derivative and make a determination of where it would be 0 or undefined, because that would give us a sense of where there would be potentially a relative extrema. All right. But we also need to determine things like global extrema. All right. Absolute extrema is another term for it. I prefer absolute extrema, but I think they like putting global in textbooks because it makes it sound fancy, I guess, more important than it is. But yeah, absolute extrema.
I think absolute sounds better than global.
Yeah. Is global recognized around
Was that a pun, right?
Well done. Yeah, an unintentional joke, but
I
quite.
have a question, but I can't describe it. Can I like draw it on the board?
Sure. Then you evaluate each critical value. Then you evaluate your endpoints. And then you start comparing. All right. Now, in the case of 12, you probably wouldn't have to do much work because that's a linear function. So you can jump. It'll glitch again 3 more times. They said I'm getting a new Apple TV, a new TV, a new computer. They didn't say when any of that is happening. Well, the new computer they said I'll get this month, but that doesn't benefit us as a class at all. Well, we'll see. This works most of the time. So linear function with a positive slope. If you were to just draw a quick sketch of this, you do something like meh and go meh, right? There's my 0, there's my 5. And you know everything you need to know, really. I mean, you don't know the numbers, at least not without investigating. You might know some of them, but you don't know both of them. One thing I can make a determination of immediately is that there are no relative extrema. There's no point where it turns around on itself. I can see that there's a low point and there's a high point. Numerically, I can figure that out just by plugging in my endpoints. All right? But let's talk procedure because it's not always going to be this easy. So first we find the derivative. But before we do that, let's make it look a little nicer. That's definitely a lot nicer than the previous form. Because I can see here very clearly that y prime would have to be 2/3. All right. Got to check the box for College Board. So I would say 2/3 cannot be equal to 0. 2/3 cannot be equal to 1/0. Therefore, no critical values. Whereas, under normal circumstances, if I were to say, are there any critical values? You'd say no, and I'd be satisfied with that. Yeah. Why? Because there aren't. It's a constant, right? So how could there be any? But the justification is what they're looking for. All right, so no critical values to worry about. So we test our endpoints. So f of 0, f of 5. Plug in a 0, you get 5/3. Plug in a 5, you get 5, right? All right, so the absolute min is 5/3. The absolute max is 5. All right, so it's one of those cases where they're asking for the y values rather than the x values. So the x values that give the absolute extrema are 0 and 5, but the absolute extrema themselves are 5/3 and 5. Right? So we got to be clear about that. Second graph is, or would be parabolic, upward facing. So you would already know, assuming the vertex falls within the interval here, where the absolute minimum would be, where relative minimum value would be. But again, you know, that requires a graph. And if you're not in the mood to construct a graph, or it's a more complicated situation where maybe you're not able to construct a graph, you need another approach. All right, so y prime, 2x plus 2, set it equal to 0. Set it equal to undefined, so 1 over 0. Disregard that immediately. Again, checking the box. I knew that there was a possibility that my derivative, if set equal to some undefined value, could yield a critical value. But then I recognized that that would not lead to a meaningful x value, so I disregarded it. College Board. On my test, I'm not taking off if you don't write that. All right? So if you just give me 2x plus 2 equals 0 and solve from there, if that other part is irrelevant, I'm not taking off. But College Board is they're gonna.
For this one, have to write continuous and differentiable.
Generally, you want to have that in mind. I want to, when taking an AP exam, always write it, but it's hit or miss. You know, in the real world, you know, you're allowed to actually just know stuff. You know, like if you're aware that it's continuous and differentiable. Now, when you get to a point where it's definitely not continuous for the original function, that's when it becomes even more important. But again, AP versus in class. So both of these are continuous and differentiable. This would also be continuous and differentiable. So it would never hurt to make that little statement there. All right. So x for my critical value, x would be equal to -1. All right. So based on the diagram we have here on the sideboard, we now know that we can have an absolute max and a relative max at the same location. All right. Relative extrema happen at critical values. So if you have a critical value, it might lead to a relative extremum. If there are no critical values, then there won't be a relative extremum. All right, just like in the case of number 12. All right, but there is one here, so it could lead to a relative max or a min. That relative max, relative min could also be absolute. All right, so it's part of the show now. So what I do is I find f of -2, f of -1, and f of 1. All right, my two endpoints and any critical values. Any critical values that fall in the domain. I'm not sure, one of these questions, I put one in here, has a critical value that does not fall within the domain, so it's irrelevant. So that's something you got to be mindful of. But plugging in these values to the original function is what we're doing here. So -4? And -5? Then -1? Yay. All right, so this would be my absolute minimum. And this would be my absolute maximum. All right, lowest and highest points. All right, so if I had only looked at the endpoints, like in number 12, well, in that case, I only needed to look at the endpoints. But let's say I completely whiffed on the idea of critical values, I would have gotten, if I just looked at the -2 and the 1, I would have gotten the incorrect absolute minimum, because this graph dips below where the endpoints are. Right, so you're looking at something like, you have your two endpoints, so here's an endpoint here, then it dips below and then comes back up. All right, so your absolute and relative min are at the same location. All right. So that's where it starts getting a little trickier. And obviously it'll become even more tricky when you get to cases that aren't polynomial based. All right, so you throw in a trig function, you throw in an absolute value function, you know, anything that's not polynomial. I don't have to list out every single possibility. What do we got? So, cubic function. Continuous and differentiable for all values of x. The next one, radical function, but it's cube root, so also continuous and differentiable. If it were an even root, that's a different story. All right, but we can go right to the derivative here. So y prime would be equal to 3x squared minus 12. Set it equal to 0. Set it equal to 1 over 0. Ditch the 1 over 0 because it doesn't make sense. You're not going to have a polynomial function be undefined if you're only using real values of x. All right, so solving my quadratic, I get critical values of 2 and negative 2. This must be the one I was talking about, yeah. So we have 2 critical values. Under ordinary circumstances, if I did not have a restricted domain, we'd go with both of them. But here I'm going only from 0 to 4. So that makes the negative 2 irrelevant. So I'm going to evaluate my original function for only 0, 2, and 4, ignoring the negative 2. So we go to 0. So 8 minus 24, negative 16. 64 minus 48, positive 16? 4 cubed is 64, right? And 48, yeah, 16. My thoughts exactly. I'll fix it in a second. Well, the negative 16 is your absolute min, and the positive 16 is your absolute max. I'll just put a help ticket in or something. All right, so we have a relative extremum, or one relative extremum. It does help if you know the nature of these functions. Before the AP exam, we're going to spend some time just kind of pre-calcing, and that is exploring different types of functions and their graphs, because back in pre-calc, it was like fun fact, like, hey, this is what a cubic function looks like, this is what a radical function looks like. You're like, oh, that's wonderful, I have a calculator. Now it's like, it would really be helpful if I knew what a lot of these graphs look like. And in a lot of cases you do, but to know, for example, that odd polynomial functions generally have a form like this is really meaningful here, because I know that for a typical cubic 5th degree, 7th degree function, anything that's got an odd power, I could be looking at multiple relative extrema, right? So a cubic function, I know that I could have at most 2 relative extrema. I say at most because it is possible that it could just kind of level up. I'm not the best at drawing this, but the idea being that it has a horizontal tangent right smack dab in the middle here, which is lower than the points to the right, but higher than the points to the left. So it's a contradictory sort of relationship. It's neither a maximum nor a minimum, all right? So having a sense of the cubic function gives you a sense of what you're supposed to be looking out for, all right? Same idea with a cube root function. If you don't know what that looks like, it can be tricky, but if you happen to know that it looks something like this, then you're in pretty good shape, because you, again, have an idea of what you're up against, all right? I'm looking at an expectation that there's probably not going to be a relative max or min, but absolute extrema are definitely fair game, all right? And in fact, if you know exactly what a cube root function looks like, you might be able to determine the answer without writing anything down, And that's pretty cool. But let's write some stuff down. Y equals x to the 1/3. Again, continuous and differentiable. The other ones were polynomials, so it wasn't really as necessary to think about it. But here you're starting to get a little funky, so we'll do it. Y prime would be 1/3 x to the negative 2/3 power, which we don't want to leave. We definitely don't want to leave it like that. 1/3x to the 2/3. Here, setting it equal to 0 doesn't make sense. I'll check the box though. Boop. I screwed that up. Just the writing. If you set it equal to 1/0, you do get a critical value of x equals 0, which does fall within the interval. So we would do f of -1, f of 0, and f of 1. So -1 gives you a -1, 0 gives you a 0, 1 gives you a 1. The lowest of these values is your absolute min. The highest is your absolute max. And so it seems as though the 0 didn't really play any kind of role within this situation one way or the other. All right? So it would be a question of, okay, so it's not an absolute extremum, but is it a relative extremum? Because it's not guaranteed to be. It's just saying that if there is a relative extremum, it must come from your set of critical values. But just because you have a critical value doesn't mean it is a relative extremum. All right? The critical values make up the set of possibilities. From that set of possibilities, you'll pull out your relative extremum. All right? And that's what we're going to explore tomorrow. All right? But what I'd like you to do for homework, so yesterday I saved the easy one for you. Today I'm going the opposite way. Rather than the textbook assignment. How about that? Okay, so one problem instead of the textbook assignment.